My name is Kunal Pariani. I'm a pre-sales engineer at NGINX. And today, the topic for my talk is service discovery in Docker using NGINX and NGINX Plus with Consul. So how many of you guys have used Consul or heard about Consul? Okay, quite a few. That's great. So the only reason I've used Consul here as a service discovery tool is it's one of the most popular tools. It has, by HashiCorp, it has a rich HTTP and a DNS interface, but it can be applied to any service discovery tool in general. So the agenda for my talk today is going to be first see what is service discovery and why it matters. Then go into seeing how open source NGINX integrates with Consul and Consul Template. And then we'll see how NGINX Plus, which is the commercial offering by NGINX Inc., makes this integration even more easier. And using HTTP-based dynamic reconfiguration API and using another method, which is DNS resolution using SRV records. We'll go into demos for both of those methods and then go into a quick comparison of both these methods and jump into a Q&A. So during the two methods, I hope you guys will pray with me because we definitely need the demo gods on our side. So service discovery. So we know microservices-based applications are quite dynamic in nature. And by dynamic, I mean service instances can go up and down at any instant of time, and they can also even change the location. So keeping track of that and staying on top of the current state of all your services is to use service discovery. And that is one of the main things you need to think about when you're designing a microservices-based architecture. So it's the process of discovering the service locations and integration of tools like Consul with something like NGINX, which can be used as a load balancer, enables automatic addition or removal of these service instances from the load balancing pool. The advantages of this, as you can guess, there's no direct modification needed to the configuration, achieving automation. And we all love saving time and effort, don't we, right? So let's first go into seeing how open source NGINX integrates with Consul and Consul Template. So this diagram shows you the complete end-to-end integration. As you can see, the backend HTTP service containers can be either web servers or app servers, which need to be load balanced here by NGINX. Another tool here which is used is Registrator, which is a service registry for Docker. It has access to the Docker API, so as and when containers get created or destroyed, it will create a service object within Registrator, which will then put this data into Consul, which is the service registry. And then on the NGINX server, there's Consul Template. Now, Consul Template is another tool by HashiCorp, which essentially is a generic template rendering tool. It requires a daemon which queries Consul and updates a fixed number of configuration templates. So every time it will query Consul and then update this templates it is supposed to rewrite on any change. And then the end user traffic, when it hits NGINX, it starts load balancing the traffic across the containers which are registered with Consul. If you need to try this, that's the link to our public GitHub repo, nginx/demos. I'll not go into doing this demo as we have two other demos. So if you want to try this, that's the link. Now, one of the limitations here when using open source NGINX is every time there's a change in Consul, Consul template will rewrite the config, and it needs to be reloaded. Now, if you're having a very dynamic environment where services are changing every few seconds, you can imagine how or run into such a situation here where there are several worker processes trying to gracefully shut down, whereas some worker processes which are trying to run with the new configuration. And this can lead to increased memory usage and eventually overload the system. Especially if you're running the server very close to its capacity, doing something like this can bring down the system. So this is where NGINX Plus can improve the integration using these two methods. First, using the HTTP-based dynamic reconfiguration API, along with the feature of Consul, which is called Consul Watches. And then the second method, which is DNS resolution using SRV records. So we'll go into both of these. So let's first go into the first method, which is the dynamic reconfiguration API method. So the dynamic reconfiguration API is essentially a RESTful HTTP API, which allows you to add or remove servers, remove backend servers, change the server parameters, mark them up or down or in a draining state, all on the fly without the need of a reload. So it directly eliminates the limitation I earlier mentioned with open source NGINX. And this is the configuration you would need to enable the use of this API. So as you can see, there is an upstream block named backend, which has a zone directive, which essentially creates a shared memory zone, which will be used by the NGINX worker processes to share the upstream configuration and its runtime state. And then there's a server block, which is just listening on port 8080 here, for example, with the location block inside which the upstream conf directive there at the bottom enables the use of this API. And one thing to note here is you want to make sure that the access to this API is restricted. So that is what we are doing here with the basic allow and deny directives. So this diagram here shows, again, the integration with NGINX Plus. Again, we have the backend HTTP service containers, which need to be load balanced. As and when they get created or destroyed, registrator being able to have the access to the Docker API, it will detect this and update the service objects and update Consul as well, which is the service registry. Now, another feature which can be used here is Consul Watches. So what Consul Watches does is every time there's a change in Consul, so there are certain types of watches Consul supports, and once that change is detected, it can invoke an external script, which is the handler script here in the diagram, which can then essentially use the Consul APIs to figure out all the healthy instances, and then use the dynamic reconfiguration API to add those instances within NGINX Plus if they are not already added. And then the end user traffic hitting NGINX Plus will just start load balancing the traffic across those backend containers. So with that, let's jump into the demo showing this. So as my demo is completely based on Docker, the two tools I'd be using here is Docker for Mac, which is, I have it running on my Mac locally, and Docker Compose, which allows you to run multi-container environments. So I have the code checked into this directory. So let's first see the Docker Compose file, which is the main file holding the service specification for all the containers we would be spinning up here. The first one is NGINX Plus, which is built from the NGINX Plus directory. It has a link to the Consul container showing the dependency, and also because it can then query it using its name directly. It exposes port 80 on the Docker host, which is mapped internally to port 80 again. Port 8080 is for the monitoring dashboard, which I will also show later. The second one is the Consul container, which is going to be started using this command. As this is the single container, starting here in a bootstrap mode. And notice that the advertise flag is using this host IP variable, which actually is the IP which needs to be used by all the Docker containers to communicate with each other. So the default gateway IP, which I have set to 172.17.01 for my case. And then the config file is the one which enables Consul watches, and I'm also going to show that. It's listening on all these ports and grabs the Progradium Consul image from Docker Hub. Now this volumes configuration option is essentially copying this JSON config file into /etc/consuld directory. And that is the script file which I'll also show, which is using both the Consul APIs and the Reconfiguration API. Also copying the host IP environment variable. The next is the registrator, which is connecting to Consul. The image is directly pulled from the Docker Hub by the image by Glider Labs. It again has a link to Consul. And notice that this volumes option, which is /var run docker.sock, is the one which allows registrator to access the Docker API. So let's go and look at the Consul watches config. So this is the config which enables the watches feature in Consul. As you can see, the type here is set to service, which tells it that we are looking to monitor only one specific service, which is our backend service, which NGINX Plus will be load balancing. And the service is HTTP. The handler here is the script file, which will be invoked. So anytime there is a change in the HTTP service, this script file will be invoked. Let's now see the script which actually does all this using of the API and reconfiguration of NGINX Plus. So it uses these two Consul APIs, the catalog endpoints to query the services. It uses the status API available in NGINX Plus to figure out the upstream group which needs to be reconfigured here. And then the upstream conf API. So we get the list of the current NGINX upstreams first here. We then loop through all the services in Consul which are tagged with production, which will be our HTTP service. And then the ones which are not present in NGINX Plus will be added using the upstream conf API, which you can see here, the upstream conf along with the arguments of add, which takes the upstream group block as an argument, and then the actual server. Also, it loops through all the NGINX upstreams then, and then the ones which are not present in Consul get removed. So it's both updating the NGINX Plus configuration with whatever is present in Consul. And now let's look at what the NGINX Plus is, how NGINX Plus is built. Let's first look at the configuration file. So there is an upstream group named backend, again a zone directive for the shared memory zone. And then this state directive is essentially all the changes which are made through this API in order to make those persistent across reloads. the state directive is used, which will save the changes on a file on the disk. Another feature I'm using here is the active health checks, which is available with NGINX Plus. Open source has only passive health checks. So as you can see, within this server block listening on port 80, within this location block, you do a proxy pass to your backend group, and then there's a health check directive with an interval of 2 seconds saying that NGINX Plus will query all the backend HTTP containers every 2 seconds, and with a match block of hello. So what active health checks does is it allows NGINX Plus to query each of the backend servers on a periodic basis, and then based on either the HTTP response code or based on the HTTP header, or you can actually look for a specific string in the response body. And that's what I'm doing here. So check for the response code 200 OK, check whether the header type is text HTML, and the body contains the string hello. If all these conditions are met, NGINX Plus marks that specific upstream as healthy. Again, the upstream conf block enables the use of that API. And then this server block, which I have listening on port 8080, simply enables the monitoring dashboard, which comes with NGINX Plus. So let me go ahead and spin up the 3 containers here first. As you can see, I have the Consul, NGINX Plus, and registrator up. Another dependency I need in order for that script to run is install JQ, which is a command line JSON processor. So just going to install that. And then the next thing is to use another Docker Compose YAML file, which will simply create this HTTP service, which is the backend for NGINX Plus. The image I'm grabbing is nginx demo/hello, which is simply a NGINX web server serving out a static index.html page with the IP address and the port number of the container, the client IP, the request URL, and some other parameters. The labels are just used to identify the service, and the tag is applied so that we can filter out specifically the backend servers which need to be load balanced. So let me go ahead and create this HTTP service as well. You can simply ignore that warning. We saw that the HTTP container also got created. So let's now go to the monitoring dashboard, which is on port 8080. And we can see that the upstream HTTP container got added automatically. This was using the script I showed and using the API. So now let's go ahead and scale up this HTTP service and see whether that reconfigures NGINX Plus automatically or not. So I'm going to scale it up to 5. And there you go. All those 5 containers got added automatically. If you want to scale down, so this shows that dynamic reconfiguration happens almost instantly. So another method here, other than using the API, is to use DNS resolution using SRB records. So let's first see what does it mean to use DNS for service discovery with Consul, or applies to any service discovery tool in general. So the DNS resolver library in NGINX can point to the DNS interface and query for all the A records or the SRV records. Currently today with open source, it can only query for the A records. There's no support for SRV. But all the A records, IP addresses it gets in the response, NGINX can load balance the traffic across those. It also has support for DNS queries over both UDP and TCP. By default, it sends queries over UDP, but if there are multiple IP addresses, a large number of IP addresses associated with a single domain, it's going to send a truncate flag set in the response, which NGINX will use to detect and switch the queries over TCP, which can handle much more IP addresses because it doesn't have the limitation of the 512-byte UDP datagram. We can also honor the TTL in the DNS response, but you can override it using the valid parameter, which I'll show later in a sample config file, along with the resolver. So as I mentioned, again, some limitations is no support. Limitations with open source is no support for DNS SRV records, A records only. So we'll see how NGINX Plus uses SRV records next. The port numbers have to be statically defined. Now this is definitely not suitable for microservices-based applications where you would have multiple containers running on the same host as well. You need to know the port information, which is important. So this is where SRV record support comes with NGINX Plus. SRV record, other than just the IP address and the A record, also includes extra information like the port number, the weight, and the priority of the service, which can then be used by NGINX to do load balancing. So as you can see here, there's a HTTP block. Within the HTTP block, there's a resolver directive pointing to the Consul's DNS interface with a valid parameter of 2 seconds, telling NGINX Plus to query Consul every 2 seconds and ignore the TTL in the DNS response. Then there's this upstream group named backends, which again has a zone directive of size 64K and a server directive pointing to the domain name service.consul. And the key parameter here is the service parameter, which enables the resolving of the SRV records. So in this case, it's HTTP telling NGINX Plus to query the SRV records for the HTTP service. And then the resolve parameter monitors the changes in these SRV records and automatically modifies the upstream configuration without the need of a reload. So again, this diagram shows the integration. You have your backend HTTP containers, web servers or application servers, which need to be load balanced. As and when they come up or go down, registrator will update the Consul service registry. And then NGINX Plus will query the Consul's DNS interface to get the most up-to-date information about the currently running services. So with that, let me jump into the demo showing this integration with the DNS method. So let's first remove all the containers we created in the last demo. And let's look at the Docker Compose YAML file here. Again, we are spinning up the NGINX Plus container. It has a link to Consul, again, exposing ports 80 for the standard web traffic and port 8080 for the monitoring dashboard. The Consul container, again, started using this command as it's a single server here for demo purpose in bootstrap mode, advertising the host IP, which was set. And the config file here is the one which I'll show later. It essentially enables the switching of the DNS traffic from UDP to TCP in case there are a large number of IP addresses returned by Consul or the SRV records. So again, grabbing the program console image from Docker Hub, it's listening on all these ports. Notice the port 8600 mapped to the internal port 53 is the one which is the DNS interface of Consul, handling both UDP as well as TCP traffic. The volumes configuration option here simply copies over that JSON config file, which I'll show next, also copying the host IP environment variable. The next is registrator, which is connecting to Consul. Again, the standard registrator image by Glider Labs from Docker Hub. It has a link to the Consul container showing, indicating the dependency. The docker.sock, again, which gives it access to the Docker API. And then our backend service, HTTP, which is, again, grabbing this simple web server image from nginx demo/hello. The labels, again, applied are HTTP and production, and it exposes port 80. So let's now see this DNS config file, which I earlier talked about. So Consul, by default, if there are more than 3 entries in the DNS response, doesn't set the truncate flag set. So in order for NGINX to switch the DNS queries from UDP to TCP, it needs this bit set. And this is what we are doing here. So telling Consul to set this truncate bit so that NGINX Plus can query in case of multiple SRV records. Let's now go into the NGINX Plus directory and see the NGINX config. So the resolver directive pointing to Consul's DNS interface, which is on port 53 with a valid timestamp of 2 seconds. There's also resolver timeout, which sets the timeout for the DNS queries. In case there's no response within 2 seconds, NGINX Plus will send the query again every 2 seconds. And then there's this upstream group named backend with the zone directive and the server directive, which is using the service parameter set to HTTP, asking it to do SRV records for the HTTP service. And again, that resolve parameter, which will monitor the changes in the SRV records and do the change on the fly without any need of a reload. And then this is, again, similar to the last demo. I'm using the active health checks feature of NGINX Plus. So within this server block, there's a listening on port 80. There's a location block, which simply does a proxy pass to the upstream group named backend, and then this health check directive. And then the 8080 port, the server block for listening on port 8080 is again for the monitoring dashboard. So let's go ahead and issue the docker compose up command. And as we can see, it created all the 4 containers, NGINX Plus, registrator, the HTTP backend service, and Consul. And that's the monitoring dashboard, which shows that the backend HTTP container was added to the upstream group. If we hit /HTTP URL, it's taking us to the backend HTTP container. So you can see it's just a simple web page showing the IP of the container, the port number, and the client IP. So let's go ahead and scale up our HTTP service and see if the reconfiguration happens again automatically. So I scaled my HTTP service up to 5 containers. And there we go. All of them are added to the upstream group. Can scale it down. That change is reflected almost immediately. So a quick comparison between these two methods, the API and the DNS, is first push versus pull. The API method is a push method because it's Consul watches triggering NGINX, which then executes a script to reconfigure itself. Whereas with the DNS-based method, it's a pull-based method where NGINX Plus is continuously querying Consul's DNS interface. So there's DNS traffic. As far as the reaction time, with the API, it's almost immediate since it's a push method. With the DNS-based method, it depends on how often NGINX Plus is querying the DNS. So again, the valid parameter, which I showed you earlier, how frequently the DNS is pulled, it will depend on that. With the integration work, the API method requires an external script, which needs to be managed, whereas with the DNS-based method, there is no need of managing an external script or no modification in the config file either. So that's a benefit to the DNS-based method. A couple of caveats. With the API, the request should be made against a healthy NGINX Plus server. If that script is issuing APIs to an NGINX Plus server which is down, it will not make any changes. So that's a thing to remember. With the DNS, again, it needs to be highly reliable. If NGINX Plus is querying a Consul DNS which is not highly available, then it will not get any records in response and then keep load balancing the traffic across the old SRV records. And with that, in case you want to try out NGINX Plus, that's the link for a free 30-day trial. If there's a need for a developer's license, that's the link to use. The password is nginx.conf 16dev. Couple of additional resources I wanted to throw out, again related to service discovery. All of them are there on nginx.com website as well. So feel free to check them out. And with that, I'll open it up for any Q&A. I will publish it soon, right after this talk, so it'll be available. Any other questions? Okay, I'll take that as a no. Thank you, guys.